Hey, I want to thank Paul and the Chicago AMS for having me up here for first time in a long time, thanks to the pandemic. My background's a little bit more complicated now that I've retired. I was a lead forecaster for the Storm Prediction Center for quite a long time, and before that, a mesoscale outlook forecaster since April of 1993. So that's a long time. And worked at the National Hurricane Center for a little over 3 years before that. So I've had a circuitous path, not as much as most NWS folks like Lee, but I have had a circuitous path. Originally grew up in Dallas. That's why my number one right there is blue and silver, because I'm a giant Cowboys fan. Always have been, always will be. There's my motto. Yeah, I need condolences. Have you seen the Dallas Mavericks lately? I need condolences. But that's my logo. I feast on the smorgasbord of atmospheric violence, both professionally and personally. Always love storm spotting, storm chasing. And of course, I have utmost admiration for everyone who is and aspires to be a storm spotter, because your role is absolutely essential to public safety. Don't ever let anyone try to diminish that. Even in the era of increased radar capabilities, such as what Mike and Lee were talking about, we're still not going to be able to compel a radar beam to go close enough to ground level to see the features that you can see with your eyeballs. And that's why it's so important that you're doing what you do, and why I have so much respect for that. I got my education at OU, so I'm always a Boomer Sooner guy too. A little bit of downtime there football-wise right now, but I will say that we're winning lots of national titles in men's and women's gymnastics and in softball. So the good times are going, just not necessarily in football at the moment. And I worked at the National Severe Storms Lab under the tutelage of some really amazing people like Don Burgess, Roger Brown, John Lewis, Chuck Doswell when I worked there. As an undergraduate student, and that's where I first got to meet those people and learn by osmosis, and some of the best there ever were. It was quite the privilege. And then I got plucked out of graduate school to be the National Hurricane Center's first entry-level meteorologist back in January of 1990. And it was amazing to work there all the way through Hurricane Andrew, which was quite the experience. Got to see a Category 5 hurricane firsthand. And then back to CELS in Kansas City. Now, CELS stood for those who are not as old as Paul, CELS stood for the Severe Local Storms Unit in Kansas City. And we were part of the National Severe Storms Forecast Center, and that's where I was working when I first did this back in the mid-1990s. And so the drive from Kansas City to here was not as long as from Norman to here, so I'm flying now. And then finally, last but not least, worked at the Storm Prediction Center in Norman when we moved down in 1996. Have been there ever since, retired a month and a half ago, and I still, because it was only a month and a half ago, I still have a lot of understanding as to what goes on there, because believe it or not, even through all this craziness of the last month and a half, we were minimally affected, as I'll show later. A little bit more background stuff. Did deploy Toto, so I am old enough to have done that back in the 1980s. It didn't weigh 400 pounds. I could pull that out of the back of the truck by myself. It was about more like 250 or so, 250 to 300. Doplight 87 project. It was just amazing for a kid like me to have learned how to drive at about age 17, and for a year and a half later to be driving around chasing storms and getting paid to do it. It was an amazing experience. IoT and E2, we were there to verify radar algorithms, so we got to punch mesocyclones at night and do stuff that we advise you not to do, but we got paid to do it, to verify that the radar was showing what we thought it might be showing at ground level. Fortunately, we didn't get blown off the road in the process. Tornadoes didn't happen much in Oklahoma in the late 80s, and that was probably good for inexperienced people like us. Participated as a forecaster in Vortex, as a chaser in Twistex with Tim Samaras and Tony Lawback and their crews, the Iowa State people. And I've done a lot of work as an author, contributor, editor for a bunch of science journals, including as a co-founder of EJSSM with Chuck and several other people. And I was at SPC for a little over 32 years, worked 35 years of continuous rotating shifts. It finally took its toll, got my house paid off, the kids are out of college, and it was time to retire from shift work. So here I am. So spotting, to me, has always been an important thing. Back in the late 70s, April 10th of 79 to be specific, this tornado hit Wichita Falls, Texas, a high contrast wedge, something you're not going to see very often anywhere, even in the southern plains. This photo appeared on the Dallas Times-Herald's front page the next day. I cut it out and put it on the wall of the room in my bedroom at home so I could see it every day when I woke up. Just an amazing, amazing tornado. Unfortunately, it also killed a lot of people. It had a horrifying impact in Wichita Falls. And it was the subject of TV shows and programs, including one called Terrible Tuesday, that some of you might remember if you're old enough to, like Paul. And that program featured, among others, Al Moeller of the National Weather Service in Fort Worth, who is the father of storm spotter training. It's because of Al that we're here. It's because of Chuck working with Al and contributing photos to that collection, including that amazing tornado in Pampa in June 8th of 1995, that we're here doing this today. Because those guys were pioneers in developing storm spotter training that led to what Lee and what Mike were able to do here, and what every WFO across the country does, adapted to their local conditions and what they tend to see the most. Whether it's lower top thunderstorms and tsunamis and wildfire problems on the West Coast, what they were talking about here, tropical cyclone tornadoes and wind effects and supercells down in Florida. And a lot of that was because of their pioneering work. And so that's why we pay respect to them today. And why I was so glad to have worked with them when they were developing that material at the lab back in the 80s. The Skywarn effort, you don't hear necessarily a lot about that term, but it's still there. The Weather Service still has a page devoted to that, as I'll show. I encourage you to look at it. And we have the Spotter Network, which you can join and contribute reports that way, as Mike mentioned. And the way I like to do it as much as anything else anymore is directly through social media. You can use X, Twitter, whatever you want to call it, and provide pictures of what's going on live, such as this tornado I saw near Prospect Valley, Colorado a few years ago. And in this case, it was in Boulder, CWA, not far east of the office. They couldn't see it. A little aside on this was actually an older mesocyclone that was getting kicked out of the back of the storm. The newer mesocyclone was way over here, okay? And what happened is a lot of the chasers were, I mean, this was a kind of a naked storm, as Walker would call it. And a lot of the chasers were leaving the older naked area for the newer naked area. Well, the problem is when you do that, what if the older one is still spinning? Somebody's got to watch that. And I would say don't give up on these areas of spin on the backside of a storm, even if something new is forming off over there and moving away. Somebody's still got to watch this. And this older area that was slowly getting kicked out of the back of the storm figure skated, tightened up, and produced that tornado. I just stayed there and photographed it, and it was a blast. It didn't hit anything or hurt anybody. So, ton of fun, but it was really important to watch for something like that. This is the web page. NWS still has it. You can Google this up, Skywarn Spotters Field Guide. There's a lot of good information there that you can just read about, that you can absorb after after being here today. And I worked on this with Tanya Franson, who's now the MIC at Portland. She was in Glasgow at the time, and a bunch of other people on this project back in early to mid 20-teens. And there's a lot there, so you can still go look at it. Hopefully our web pages will stay up for the next few months. Spotting, chasing, and science. And I'm going to lump together spotting and chasing briefly for a moment or two, although as everybody's rightly been saying, there's a lot of separation there, as Mike in particular has been saying. Storm observing, okay? Conscientious, purposeful storm observing. I think there's a role of that for spotters and chasers. That's where our Venn diagrams overlap, because the chasers who do so conscientiously are not just out there screaming, yelling, live streaming video, ah, woohoo, look at us, we're tornado cowboys, you know, none of that kind of stuff. Out there trying to contribute as well, to learn and contribute. And if we're not trying to learn, why are we out there, really? As a spotter, you're not only watching for hazardous conditions, you're learning from what you're seeing, because you'll never see the same storm twice, ever. You'll see something different every time, and it won't look exactly like what Mike was showing, and it won't look exactly like what Walker was showing in those amazing time lapses. It'll look a little different. So you'll have to adapt your conceptual model to different things. And it's possible you may see something that no one else has yet. And if you have, that can contribute to the science. Walker's mentioned in some events that produced, I think Rochelle, it produced a satellite tornado. I did some research on those a few years back using pictures that were contributed by spotters and chasers, pictures and video frames, and documented the environments of these and how often they happened and where they happened. And as a hint, they tend to happen in strong to violent tornado environments like Rochelle, not all of them, but some of them. And like this, EF5, not Bridge Creek, that was May 3rd, 99, that's up there. EF5 in Piedmont, Oklahoma, back in 2011, had a satellite tornado. I actually had more than one. And that's Greensburg. EF5 in Kansas had several satellite tornadoes. And even some strong tornadoes such as these in the Panhandle. Again, May 3rd on the upper left, New Mexico storm that didn't hit much, so it didn't get a big damage rating. But those things can contribute to scientific understanding. In this case, wrote a paper based on a storm, anticyclonic storm, that didn't look like this. It was these are two pictures. The real storm looked like what you see on the left. The mirrored image of it is on the right, that looks like a normal supercell that we saw in Colorado. So we were able to relate, using the Lemon-Doswell 1979 schematic, a version of that, what the left mover did and should look like. And it's something like this, where you have a clockwise or anticyclonically spinning mesocyclone with a storm that's moving to the north and has its storm relative inflow coming in from the north, a mirror image of what you would normally see. And I'll ask a question for y'all. If you've got air coming out of the rear flank downdraft of an anticyclonic or clockwise spinning supercell, left mover, notice what direction it's moving. It's turning cyclonically or counterclockwise. That in turn was an important conceptual model for yet another study, this one that Rich and I did, that we published as my last formal paper as an SPC forecaster, which involved a case on May 29th of 2012 where we had a left mover. That's the storm that's called LM. The gust front from that hit a right mover. The mesocyclone tightened as soon as that gust front hit the mesocyclone of the right mover and produced this dusty tornado with a subvortex. Rich and I successfully forecast that this might happen about an hour in advance and decided to be at that location. Not because of any published paper, but because of conceptual schematics swirling around cyclonically and anticyclonically on either side of our brains that indicated that something like that could happen. And so we decided to be there, and it actually worked out. Eventually, the tornado formed a little cone while we were trying to get away from it because we were too close. And and then got undercut by cold air from the outflow. But we were able to successfully forecast that case and then draw a conceptual model for the two storms interacting. So we're taking this Lemon-Doswell thing, which looks really simple, and really making a big complicated mess out of it. But again, it's all just a bunch of fun fluid flow. So what we're seeing is we're seeing this cyclonically curving air with cyclonic vorticity along that far rear flank gust front of the left mover, smack into the mesocyclone of the right mover, positive or cyclonic vorticity, added to cyclonic vorticity, tightened it up, spun up, produced a tornado. Meanwhile, at the Storm Prediction Center, Matt Mosier saw the same thing happening. Who replaced me as lead forecaster? Matt saw the same thing happening, wrote it in a mesoscale discussion, and said the outflow from this left mover might increase the tornado potential of the right mover when it hits it. Wrote that in a mesoscale discussion, it happened. So we're thinking these things independently. Rich and I in the field, man at the SPC. We put that in that paper. Fascinating. We didn't publish it until last year because we were actually ahead of some theoretical modeling that modeled this finally out of Texas Tech, that modeled this type of interaction, so we referred to that. And that way we could tie it in more with theory and have it be a real science effort as opposed to just a show and tell paper. So it was a really neat piece of work, and it was all because of storm observing and spotting. You can contribute to the science. You can contribute back to the understanding of severe weather, because if you do this long enough, you'll see something that nobody else ever has before. Or they did, and it's not quite understood all that well. So I hope that that serves as an example. Here's another one. This was a case, again, Piedmont EF5 back in 2011, where you see ERPT, El Reno Piedmont Tornadoes, what that stands for. Okay, this is from a research paper by Mike French and several others who were at OU at the time. And then Tornado 2, a satellite that formed in an area of the tail cloud on the forward flank ahead of the mesocyclone, started to rotate around the main tornado. So it formed independently, but then it became a satellite tornado. But unlike most such events that just satellite tornado dissipates, this one physically got absorbed with and merged into the main tornado, which had never been observed before. And I happened to be there to shoot distant, low-resolution pictures of that, but then not so distant, not so resolution pictures of that big, loud wedge that formed after the tornadoes merged into each other, and contribute that to the research paper. And what was funny is I got this paper. They didn't even know about my photos. I got the paper for review. It landed on in my inbox. Would you be willing to review this? Oh, El Reno Piedmont merger. Holy crap, yes, I would be interested in reviewing this. Because I photographed this process. So imagine their surprise when they get from the reviewer photos of this very thing that they're talking about a mobile radar observation of. And I'm shooting photos of it. Needless to say, they were pretty happy that someone actually got photos of this thing. So again, if properly positioned, you can contribute to the science. I'm going to switch a little bit about the SPC, because this is really the heart of the talk. We're currently located in the National Weather Center, or sometimes I call it Battlestar Norman, south of the OU campus, on campus, but on the southern edge of campus. We have high-level forecasting responsibility. We forecast for the entire nation, severe weather, a little bit of winter weather, a little bit of fire weather, mostly severe, which is what I'm going to focus on today. We have outlooks days 4 through 8, days 3 and 2, and then day 1 outlooks. And the outlooks increase in frequency and in resolution as you get closer to the event. And then we issue mesoscale discussions for those not as familiar with our product suite. And then we keep drilling down the forecast funnel to finer and finer resolutions and issue severe weather watches. And then from there, the local NWS forecast office picks up the warnings, like they do here at Romeoville for Northeast Illinois. And then we also issue a bunch of products that are not operational or urgent. severe weather report listings, severe weather tornado death counts, and listings for strong and violent tornadoes every year, maps that are online. We also put out forecast guidance. A lot of you look at our meso-analysis pages. I've got some really sweet, juicy eye candy to show you later. Walker talked about the burgers and the fries and the onions and all that stuff. I'll show you some delicious dessert. And we put a lot of our scientific research online. I mean, I was really pleased and honored to be able to participate in a lot of research projects over my career. I think I have 10 formal publications as a full-time forecaster, lead authored. I don't know how many, probably 40 or 50 that I've co-authored on, plus a ton of conference papers. And it was all aimed at improving severe weather science. Here's the SPC staff page. And I want to make a couple of notes on this. The red arrows are ongoing vacancies, and this is as of 2 days ago. It hasn't changed since then as far as I know. None of these vacancies have anything to do with the ongoing craziness. This was coming into this year, this is coming into this month. These are vacancies that are ongoing. There's been a massive shell game all around the National Weather Service where there's been a lot of vacancies that have been going on for months and months and sometimes years at a time at some forecast offices. And then they get filled and then there's a vacancy elsewhere, and they get filled and there's a vacancy elsewhere. And the net number of vacancies doesn't change a whole lot, and it's been a problem not just this year, but since around 2010 or so. And even during years where the NWS has gotten the money to fill the vacancies, for some reason they haven't been filled. Where's the money gone? I don't know. I was at the bottom of the totem pole. I wasn't told. So we keep having these vacancies. So the vacancy problem in the Weather Service, again, it's not new. It's just a little bit worse now than it was, now that we've had a lot of retirees under the fork in the road thing. SPC has not had any such problem. We're minimally affected by the current trouble, but we're still affected by the ongoing trouble that precedes this year. And we also have some non-federal people as well. I'll focus on the forecast desk. There's 5 lead forecasters, 10 mesoscale outlook forecasters, and nominally 7 mesoscale assistant forecasters. Again, you can see we have a couple of vacancies in the severe weather forecast side and a couple in the fire weather forecast side that will not be filled anytime soon due to the hiring freeze. So we go into severe weather season with quite a few vacancies, actually, both administratively in the support side and also in the forecast side. Nonetheless, we do the best we can. Forecasting itself, what do? We've got all kinds of great tools, but it all starts up here, okay, with education and training, conceptualization, and understanding. How do you achieve understanding? Al Mohler has a great video online. Paul interviewed him. This is back in the 90s. What year was that, Paul? 1991. Wow. It's called Zen and Forecasting. Google it up. Look it up on YouTube. It's a great video if you're interested in the mindset behind immersively understanding how to forecast weather. Great, great video. That sort of forecast mentality has always driven me because Al and Chuck were major, major mentors of mine early on. Every good forecast starts with time zero, the analysis, what has happened up until recently and what's happening now. So every shift I ever worked at the SPC, I did multiple surface and or upper air charts with pencil and paper to swim in the data and understand it optimally. And it gives you an understanding that you're not going to get from quick looks at objectively analyzed fields on screens. And swimming in the data and true immersive understanding has a lot of value in the forecast process. And I will argue that until the day I keel over. But it's less and less common, unfortunately. So this is a surface analysis, and it's actually a fairly typical one for me. It looks like somebody ate a bunch of paint and barfed it out on the screen. But to a mesoanalyst, to a forecaster, this will have meaning in terms of where boundaries are and maxima and minima. And even in a forecast desk, I will admit this is a little bit extreme, just a little bit. But again, this was a very chaotic situation. It wasn't classic dry line, cold front, warm front. This was a messy, warm season day, June 22nd. So what kind of tools do we use? This mesoscale discussion exhibits it. Pretty much everything under the sun that we can, satellite, radar, upper air observations. By the way, thanks to the ongoing cuts, we have 2 fewer of them now that we pretty much lost Gray, Maine and Albany, New York yesterday. And we lost Chatham to erosion, haven't got that one back. We don't have Denver, we don't have Tallahassee, I think, due to a hydrogen helium problem of some sort. We're losing observations. That's not going to help either human or model forecasts, something to keep in mind. But we have access to all that in the form of soundings, in the form of planar plots like this, and we can analyze that and determine where we have changes in various fields and winds at different heights and pressure in different heights. And we can even depict that in these mesoscale discussions in the graphics. We have access to radar, which helps us in real time to conceive what the storm is doing. We have access to storm reports. This one was via Spotter Network. This was an absolutely excellent report, and I want to use this as a shining example. If you're going to report a feature in a thunderstorm, and Paul loves wall clouds, they're his favorite thing in the world, okay? And here was one of his reports of a wall cloud, not rotating. And I want to read this real quick. This storm has improved its visual appearance over the last 20 minutes. So he's not just saying, tornado now, and not even giving a location. No, there's no tornado. He is saying what it has done, what it is doing in good detail, okay? Wall cloud is surrounded by a shelf cloud along the RFD. We saw that in the talks earlier. A small tail is showing rather strong vertical ascent as a beaver's tail is evident along the forward flank. The RFD does not yet show a clear cut into the wall cloud. Low-level rotation is increasing. That is tremendously useful to the local forecaster, right? Because it tells them exactly things that you cannot see on radar. It says how a storm is evolving, where it's been, where it's at now, and it's still short enough to fit in one bubble. So it's concise, but it's packed full of information. Your local forecasters at the NWS, whether it's Romeoville or if you're up in Milwaukee, CWA or Davenport's or wherever, Lincoln, they love this kind of stuff. They love this kind of detail if you're able to provide it and it's safe to do so. So use that as kind of a great example. Mesoanalysis, of course, we developed this. We use it frequently. We have an internal display where we can do 4 panels. We can animate these. We can move them hour to hour. Observations, again, we depend on observations so heavily. Sounding tools, analysis tools of all kinds. We can just dig into the atmosphere every which way with these. We even sometimes look at webcams to get ideas of what's going on. This is the Evansville tornado from a long time ago now, from a hospital webcam, and we actually could see that real time. All that time spent on diagnostics and observations, I'm only going to spend a little bit of time on models because when we get down to day one, they're actually not that big of a part of the forecast process. It's really more about understanding and about diagnostics. But we do look at the very latest and greatest, not only the synoptic models like the GFS and the NAM and end symbols of the GFS, but we look at the convection line models like the HRRRRRRR and end symbols of these models to give us an idea as to what sort of environment might be supporting this kind of stuff later. The most important tool is this, by far, okay? The models don't mean much and the observations don't mean much without understanding. And that really is the most important tool. And I fear that as we lose the institutional knowledge of experience, not just at SPC over the next few years, as people that are my age or even older like Paul retire. And so as a result, we may lose institutional knowledge and weather service wide. And there's brilliant young people coming up. Don't get me wrong. I'm not trying to say, well, the weather service is going to go into hell in a handbasket because no. We're in good hands, as I said in the last Outlook. We're in good hands, but we have to keep it that way. And that's what's really important. Day 4 through 8 outlooks. How can you use these as a spotter? Well, day 4 through 8 outlooks are important because, let's say, you know, like earlier was being talked about, you know, your kids might have a softball game on Tuesday but not on Monday, or whatever, or a baseball game, t-ball, whatever. I might need to go out spotting this day. Well, you know, will I need to go spotting this day if I'm, let's say, in the Boot Heel of Missouri? Maybe. That outlook's awfully close and it's 7 days out. I'll at least keep an eye on that. It would be wise to do that even if you're not in that area, because the further out you go, the more uncertainty there is, and that's why we only draw usually one line that far out. So let's go in another day on the same outlook. Uh-oh, look at there. Well, now the Boot Hill's included, as well as a little more Tennessee, and the severe weather threats really ramping up around Shreveport and the Arklamis. So if you're a spotter there, and it's a really tough place to spot because of trees and terrain in some cases, you might start thinking about, if you haven't yet, places that you want to go to be able to safely observe, and with an escape route, usually to the south or southeast. Thinking about things like that if you haven't already. Oh, as we get closer, day 5, well, what's going on? Well, the outlook's changing a lot around the edges, but it sure is focused on that core area around the Mid-South. So that means that they're really confident severe weather is going to occur in that area on that day, even if the periphery is changing. But even if you're on the periphery, stay prepared and be ready. You might need to be activated on that day. Day 4, well, the confidence is not increasing in an outbreak, but in a severe weather scenario that still stays at enhanced levels. It doesn't necessarily ramp up in risk, but it might ramp up in confidence that that's the area that the storms are going to occur. And so by this time, 4 days out, if you've got 3 or 4 days worth of outlooks in the same spot, as a spotter, you can tell maybe your folks at work or your family, you know, on this day, I'm probably going to need to go out and spot storms. That's how useful that can be. You can plan in advance to some extent. And then when you get to the day 3 outlook, this is actually for a different event, but in theory, let's say it did expand to the north a little bit, then you can include those areas as well. Oh, it got enhanced. Big day potentially, with some significant severe possible over a large area. A lot of offices are going to be affected. Now that we're short-staffed, maybe some offices are going to be backing up other offices with warnings because some of them are down to only a couple of forecasters. They may badly need the help that spotters can provide, because some of the forecast offices might be a bit overwhelmed due to staffing problems. Day 2 and day 1 outlooks. This was for May 3rd, 99. Back then, we could go from slight to high, and we only had categorical outlooks, not probabilistic ones. Now we've got probabilistic ones, and we can gauge risk within risk. Category, you've seen the tornado, the gust, the hail outlooks. So as a spotter, you can sort of plan in your mind, okay, what do I really need to look out for? Is it going to be more of a big-time tornado threat, or I'm going to be dealing more with hail or wind or some combination of all three? In this case, mostly all three. Here's a product that we send to local forecast offices that we make available to WFOs and to emergency managers and FEMA. That has state outlines and centered on the risk area, and we often put this on our webpage the day of the event and on social media. It highlights the threat. Key messages, you'll see these. You can use these for, in this case, it was a day 2 outlook, day 1 outlook, the primary risks that are expected, the safety actions that you can give to your family and friends as to what to expect. When you see these things show up, point them to them. And then, of course, timing information, what's likely to happen. Used to be we wrote mesoscale discussions like this that had a bunch of abbreviations and a bunch of capital letters and didn't mean a whole lot to most people. Now they become a lot more descriptive, contain a lot more information, and they can be useful. When you see, for example, something like this with favorable looking photographs on it near the warm front, that might be a clue that maybe up here you'll deal more with supercells or line embedded supercells, and further south maybe messier structures or not as many storms. These are considerations you can use when you're out there, and you can use these mesoscale discussions to inform your understanding of how the storms are likely to behave and why. And then, of course, watches. We talked about those. These are watches on May 3rd, 1999. They were just polygons, and now we're issuing watches for counties, and they move along. The one on the right was for Hurricane Harvey in Houston. They were in a tornado watch for over 60 hours, multiple tornado watches. It was a tough deal down there. And of course, watches contain detail like this, the probability of different kinds of severe weather. You can use those as well to anticipate what you might have to look at. So what's coming up? What's next? And I'll go through this sort of fast since time is running low. But we're in the process right now of rolling out probabilities of hazards and intensity of hazards within each mesoscale discussion area. So if you look at the mesoscale discussions, you'll see the potential for most probable peak intensity of tornado, wind, and hail. And the peak intensity of tornado, they're broad estimates. They're based on historic events that were rated using the EF scale wind estimates, which are all estimates. That's why these are broad. Wind and hail climatologies are factored in with environment to give us a most likely peak of these things. And this is for the Barnsdall tornado, which was an EF4 about that time. In fact, even on this resolution, you can see this curly Q of a hook with a debris ball there. It was Barnsdall, Oklahoma. Some of the other things that are either happening or eventually hopefully will be released that are being tested right now is timing-based Outlook information at localities where you can click on a map if you're in the Outlook and get the timing of different things that may hit. WFOs have access to some of this information now. Continuous probabilities. The lines are not hard, fast edges that say, well, you've got much less of potential here than you do here 5 miles away. They're really more continuous spectra. They're smoothed out, and we want to reflect that. We've been working on this, and hopefully can get it out here in the next couple of years. National mesoanalysis. You've seen a version of this that we have online. Well, we're going to improve on that. Now they're fixed sectors nationwide. We're going to make it to where you can roam and zoom in and zoom out and look at different fields to your heart's content at much higher resolutions than you could before. And I think this will be very, very beneficial and popular for a lot of chasers, spotters, WFOs, a lot of people. We look at machine learning guidance. We don't use it as a crutch. We use it as a tool, just like anything else, but we're aware of it and we use it. And you can see how different it is. These are not panaceas. It's not gospel. Different guidance produces different outputs. But if you're seeing consistent output in an area where you've already made the forecast, it can increase, or in the case of if it's not in your area, decrease confidence in your forecast. We can produce guidance matrices that show the potential for different exceedance probabilities. In other words, what is the potential that we'll get an EF2 or greater tornado in this area? 91% in something like that, for example. This is being tested internally, and once that gets refined, that'll go out as well. We call those conditional intensity groupings, or SIGs, as you can see by the burning cigarette up at the upper left. We can even predict now using machine learning guidance what the probabilities are that our forecasters later in the day will issue a watch, where they'll issue the watch, and what type of watch it'll be. And that's actually kind of useful for us internally. Let's say I'm doing the 13Z Outlook, and I have a question as to whether to include the area because it's kind of on the borderline. And if this tells me that a watch is highly probable later today, well, I better have it in an Outlook, unless there's a strong meteorological reason not to. The automation risk, however, I will go through this quickly too, is pretty high because we have to maintain proficiency even in the era of AI and automation. And the reason is this incident. How many of y'all are familiar with Air France 447? What happened there? Okay, well, you can sleep for a minute. But it has lessons in meteorology and really in every aspect of life. Consistent, mindful involvement, even if you depend on automation. No plane like this had ever crashed before. Icing of a sensor caused a problem that they did not know how to react to properly because of inexperience with non-automated situations. And as a result, we had a terrible, terrible disaster as the plane flew into ITCZ thunderstorms, tropical convergence zone storms over the Atlantic. These are the most important aspects of it, is that as we use automated guidance, manual control becomes more important. Now that seems a little bit counterintuitive, but because in atypical conditions, the automated guidance is more and more prone to failure, you need to know how to override it, overcome it, and what to do when it does fail. What is a tornado outbreak or a horrible derecho? Atypical conditions. So even as we as forecasters use more and more automated guidance, we need to maintain proficiency and learn how to overcome that and override that when necessary. Major lesson. So that'll finish that off. This is what's up for me. Doing a lot more of all these things, but I'm not, as I told folks at work, I'm not retiring from the science, just some rotating shift work. And I'll just put this up here. These are some web pages. There's contact info if you want to email me with questions after this. My Twitter, X handle, web pages if you want to go and look at those. Photography, image of the week, maintain those. And I guess we'll do questions in the big session. Thank you.